This conference will now be recorded.
Okay, before we get into bitwise, like the Karthik and Datta, you know what is the binary number, right? So computers store information in the form
0.
of, yeah, zeros and ones, binary, zero. So even if we give, no, even if we write some 5 plus 2, it is not going to calculate as 5 plus 2. In fact, internally, it's going to be like bin 5. Bin is a method or a function that helps us to get the binary number of the number. Here B indicates the binary number, so doesn't make it doesn't have any other meaning for it. It's only B is only here to represent that it's a binary number. Basically, it is nothing but 0101. Okay, how do we calculate 0101? I mean, how can we make it back to 5? Thing is, let me open it now. Suppose binary number, as I said, like it's 0101, right? 0101, binary number of 5. Can I increase the font size here? Font. All right. There's nothing but 0 multiplied by 2 to the power 3 plus 1 multiplied by 2 to the power 2. 0 multiplied by 2 to the power 1 and 1 multiplied by 2 to the power 0, right? Here it starts with 0, 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. Usually, computers store in the 64-bit machine. We have two kinds of systems, right? 32-bit and 64-bit. 32-bit means it's going to have like 0, 0, 0, 0, 0, 0, 0, 0, and so on for 32. Right here, for simplicity, I have taken it as a 4-bit. It's 0, okay, 0, this 0 is this one, and 2 to the power. The result is 0 plus 1 multiplied by 2 to the power is 4 plus 0 plus 1 multiplied by 2 to the power 0, 2 to the power 0 is 1. So it's 1. Right. This is 5. Right. So understood? Any questions on this? Like how can we calculate a binary number to an integer? I mean, how can we convert a binary number to an integer?
No.
Yeah. Let's take binary number of 8. Okay, let me show you another thing, like 0b 0b101, right? Binary number. You can see we can convert using int method to convert back a binary number to an integer. 2 here indicates this the binary number. I mean, we need to convert this back to normal integer decimal system. And let's take another example. Sorry, 8. Okay, let's calculate this. 0b10100, right? Karthik, 0b10
0.
is the number. Yeah,
0.
0. This is a binary number of 8. Let's calculate this back to integer. We know how to do this using int method. Int 0b100, 2. So we got 8. Let's do it manually. Yeah, and b is not necessary. B here just indicates that it's a binary number. Yeah, go ahead.
0 into
0 multiplied
2
by
to the 2
2 to the
power
power
3.
see,
1
this
1
is
1
yeah,
into, yeah, 1
yeah.
into
There is an 8-bit one. 2 to the power
0. Oh, this is 1 into, right? 1 into 2 to the power of 3
okay, you can do
from here, right?
1 into 2 to the power 3
3 plus 0 into 2 to the power 2. 0 into 2 to the power of 1.
0 multiplied by 2 to the power 0.
0.
So this is all 0
8.
multiplied by. So 0 multiplied by any number is 0. So it's going to be 8 plus 0 is equal to 8, right?
Yes.
Let's calculate another one. Dattatreya. Binary number of, let's take 10. 0b
0 0 0 0.
0b 1010, right?
Yes.
Okay, go ahead.
1 hashtag 2 cap 3
2 to the power 3
plus 0 hashtag 2 cap 2
up to
plus 1 hashtag 2 cap 1
power 1.
plus 0 hashtag 2 cap 0.
Yeah,
That is 8
and
plus 2.
8 plus
Yeah,
0 plus 2 plus 0, right?
0. Yes.
It's 10. Okay. Now we understood like how to convert. Sorry. How can we convert this to an integer using int method? Int the binary number comma 2. 2 indicates it's a decimal number, right? Now get back to bitwise operators.
Sir, here 2 indicates base, sir.
It's a decimal number. 2 indicates the decimal number. That's it.
Yeah, okay.
Yeah, bitwise and let's do this 5 and 2. So here we are doing like 5 bitwise and 2. We got 0, right? So let's calculate how we got 0. Binary number of 5 is this one, and binary number of 2 is this one. It's like 0 window 5 is 0b1. Let's write it like 0101, right? Binary of 2 is 0010. Now we need to calculate 5 and 2, right? It's going to be like 0101 and 0010. Let's write it like this: 0101 0010. And what we need to calculate is binary name, bitwise AND. Let me show you a table. This is the way we need to calculate. Yeah, here we have the table, right? It's bitwise AND. If we have 0 and 0, it's going to be 0. If we have 0 and 1, it's going to be 0. If we have 1 and 0, it's going to be 0 again. Only when we have both ones, we're going to get 0. When we have both ones, it's going to be 1. Based on this table, just tell me what are we going to get here? 0. Let's start from here. Maybe yeah, from left. 0 0 is going to be
0.
0
right. 0 0 is 0. Okay. Let's put it together. Yeah. 0 0 0 1 0
0
Okay, 0 1
0
1 0,
0.
and if we calculate this back, it's going to be like 0 multiplied by something, right? This, so 0 multiplied by any number, it's going to be zeros. That is why we got 0 here, right? By 5 and 2, we got 0, right? This is the reason why we got 0. Let's take another example. Karthik, it's going to be 8 and 4. Explain me how we got, okay, something else, like some number. But there is no other, instead of zeros, is there any other thing that we can get? 3 multiplied by 4, 5. Okay, we got 1 here. So let's calculate the binary numbers first. Binary of 3 is what? 0 0 1 0. 0 binary of 3 is 0 0 1 1, right?
Yes.
And binary of 5 is, we already have this,
Yeah.
0
0 1 0.
0 1 0. Yeah. Now 0 0 1 1, 0 1 0 1. Yeah. Go ahead and explain.
Yeah.
Based
0
on,
0 0 1.
yeah, 0 0 0 1. And obviously it is 1. That is why
1.
we got 1 here, right?
Yes.
And yeah, Dattatreya, and let's take another number. What do we get? Okay, we got 8 here. Let's do this then. Dattatreya, binary number of 8 is 1. Binary number of 8 is 1 0 0. Binary number of 9 is 1 0 0 1. Yeah. Dattatreya?
Yeah, 1 0 0 0.
1
Again
0
8.
0 0. It's going to be
8.
1 multiplied by 2 to the power 3 and plus remaining and all 0, right? That's why we got 8 here. And let's do it for bitwise OR. We have table here, bitwise OR. Where is that one? Yeah, a bitwise OR here. Instead of and, let's do this. And we got 9, 8 or 9. Explain this.
1 0 0 1.
1 1 0 0 1,
1.
and it's going to be like 8
Plus
8 plus 0 plus 0
0.
plus 1. That's why we
Right.
got 9, right? And let's do it for this one. So 3, Karthik, we got 7
Yeah.
here. Let's do this. And 3 5, right? And 3 binary number of 3 is 0 0 0 1 1, and binary number of 5 0 1 0 1.
0 1.
Yeah, go ahead.
It's 0
0. Let me show the table. Yeah, here we have. Yeah, go ahead. This is the
1.
one.
Yes, yes.
1
All ones. 1 1 1.
1. So it's going to be like 0 plus 2 to the power
4.
4, right?
4.
4.
Yeah, 4 plus 2 plus 1.
2 plus 1. So 4 plus 2 plus 1 is 7.
7.
That is why we got 7 here. And let's do it for okay, negation we will do it at the end. And we The next one is XOR. For 3 and 5, XOR or CAP. Let's do this. Yeah, here we have the table. Karthik, it's 3 and 5.
Yeah.
Let's see the output first. What do we get? 6 we got. And there's the table. Go ahead.
Yes. 0,
0, 1,
1, 1,
1,
0,
again 1. Okay.
0.
Let's go. Yeah. Here
Like
it's going to be like this: 0 plus 4 plus
4
2
plus
plus
2
0,
plus
right?
0 is 6.
That's why we got 6. It matches with the result. Okay, and the next one is right shift and left shift. Right shift and left shift can be explained better with. Okay, let's define this one itself. So usually let's take 8-bit machine, binary 3. We're going to have like 0000, 0011, right? If we right shift it, it is going to push from here. So let's take right shift of 2. It is going to push 2 places. So it's going to remove the last 2 values. Did you get the point? If we left shift it, this is basically 1 1, right? This is going to remove the first 2 values and place 2 values here. So it's going to be like this. I think it's better to explain with Excel. Let's take binary number of 3 itself. So 0 0 1 1, right? This is a 4-bit machine. Let's take 1 2 3 4 1. Okay. Yeah, this is an 8-bit. Let's take 8-bit machine. So it's going to be like 1 1 0 0. The remaining are all zeros. How many we have? 8. Let's take this is an 8-bit machine. So if we go for right shift, let's say 2 places, it is going to push from here. So the last 2 values will spill out. Delete it. Right? So up to here, just cut it and place it here. The first 2 values will get zeros as it doesn't have anything. Did you get it? What is the right shift one? When we mention 2, it's going to push it towards right. The last 2
Sir,
values,
your
whatever.
screen was not visible completely.
Huh?
That
Okay.
was partially covered.
Now you can see it, right?
Yeah, now I have yeah, 8 zeros I have, yeah.
Yeah, right. I think it's you have to minimize this chat window.
Mm-hmm.
Karthik, any questions on this? Right
No,
shift
nothing.
or left?
So it,
Yeah, right shift or left
yeah,
shift is
yeah.
nothing but pushing towards right or left
Okay.
in terms of binary numbers. Here we got 0, right? Let's take an example. Let's delete this. Uh, 3 2, right? So we got 0. So it matches with the value, right? Here we all have zeros. Let's do left shift, the same 3. Here we got 12, and let's find out why we got 12. This is 3, right? So we have to left shift. We have to do the left shift, and two places in the sense, here at the end we get two other values, like it's going to be like this, right? So based on this we can get somewhere around, let's take 0, this is 0, 2 to the power 2, right? This is, and this is 2 to the power 3.
3.
So it's going to be 4 and 8.
8.
The total is 12. I think it matches with the result. Yeah, it matches with the result, right? And Dattatreya, explain why we got 20. What is the binary value of 5? Binary value of 5 is 0101. Let's delete this. Okay. Let's remove this, but delete column and yeah, Dattatreya, go ahead. What is the binary value of 5? 0101, right? This is going to be 0, 1, 0, 1. Okay. Now we have to do left shift 2. Dattatreya, what we have to do now?
0 0
So left shift in the sense we need to add. Let's add two columns. Here we have 0 and 0. Now we can simply calculate it, right? This is going to be so it's 2 to the
2
power
square.
2, right? 2 square. And this
Yep.
is going to be 2 to the power 4.
4.
Yeah. And this is 4. And this is 16. The total is
20.
20.
That is why we got 20 here. Where is it? Yeah. Let's do right shift. And we got 1. So let's do right shift. Let me undo. Yeah. Explain it. Like Karthik, the right shift of 5. Here we have the binary number of 5. Let's do right shift. Let me change it here.
And this
It's better
this
to
process.
add a column here, right? So add a
Yes.
column. Where is that? Don't we have an option to add? Okay, let's do this. Let me cut it and place it here and add zeros, right?
0, 0. Yes, correct.
Yeah, now it is like
There. These two will be erased.
this is going to be 1. Okay, these two will get erased,
Will
right?
get delete.
Yeah. Delete
It will
columns.
2 to the power
This is 1, 2 to the power 0.
0.
Remaining and all zeros. So 2 to the power 0 is 1. That is why we got 1 here, right? Okay,
Yes.
we understood what is right shift and left shift. Let's discuss about tilde or like negation. This bit interesting. This unrow operator, and 8 is 9. Bitwise negate of 8 is 9. Let's do it for 7 minus 8. Let me explain you how we got negation of 8. Negation of 7 is minus 8. Negation of 8 is minus 9. Let's close this. So negation of, let's take 7, right? So binary, what is the binary number of 7? Binary number of 7 is 0, 1, 1, 1. Before we get into this one, we need to understand the sign bit. The first bit is going to be sign bit. 0 indicates it's a positive number. If it has 1, it indicates a negative number. Okay, understood? So here we have 0, right? This indicates the positive number. In fact, 7 is a positive number. Let's do it for, let's take -8. Okay, 1, 0, 0, right? Binary number of 8 is 1, 0, 0, 0. In fact, internally it stores like this. The first bit is 1. 1 indicates, sorry, this is 8, right? -8. Yeah. The 1 indicates it's a negative number. This is how it internally stores. Any questions on this?
No.
Okay, it's just the bit, the first bit. It flips. For negative numbers, it is 1. For positive numbers, it's going to be 0. And let's do this. Okay. Okay. And negating is nothing but flipping the values. We have 1, 0, 0, right? 1, 0, 0, right? Negation of 1, 0, 0 is like this. 0, 1, 1, 1. Okay. So negation in the sense, the table, let me show the table. Negation of, yeah, here we have. 0, 0 will become 1 and 1 will become 0. That is number 1. So negation or tilde or negate will turn zeros to 1 and 1s to 0. In order to calculate negation of some number, what we have to do is we need to calculate the 2's complement. Before we get into 2's complement, let's discuss about 1's complement. 1's complement is nothing but negation. So if we have 1, 0, 0, it is going to be like 0, 1, 1, 1. Okay. Even though these two are different things, 1's complement is almost like negation. And second complement is first complement plus or minus 1. Plus or minus 1. And then the question is like when we need to add or when we need to subtract, it depends on the value that we have to calculate. If it is a negative number, we need to subtract. If it is a positive number, we need to add 1, right? So basically what, like if we go for tilde, that is a negation of some number, it is going to be like this. First of all, we need to negate, we need to calculate the binary number and we need to flip the values of the bit values and then 1's complement, and then we need to add plus or minus, like if it is a positive number, we need to add 1. If it is a negative number, we need to subtract 1. Any questions on? We will see an example how we can calculate it. This is how it works. If we give a negation of number, this is what happens: binary number, and then flip the bit values as a negative number, a negation of some number. This is how it's going to be. Flip the bit values and then first complement, and then add or subtract based on the type of the value, whether it is a negative value or a positive value. Okay, let's take an example. If we have 8, okay, you can see my screen, right? If we have 8, what is the binary number of 8? It is 0, 1, 0, 0, 0, right? If we take as an 8-bit one, it is going to be like this: 1, 1, 1, 1, 0, 1, 1, 1. What are we doing here? First of all, negation, like we need to flip the bit values because we are negating it. Karthik, any questions till now?
No, nothing is.
Here, the first bit is a sign bit. Okay, first bit is sign bit, and based on this, whether the result is going to be a negative number or positive number. 1, 1, 1, 1, 0, 1, 1, 1. The first bit is 1. Is it a negative
1.
number or positive number?
Negative number.
Negative number. So we need to keep the sign bit aside. The remaining values like 1, 1, 1, 0, 1, 1, 1. So for this, we need to calculate 1's complement. 1's complement of 1, 1, 1, 0, 1, 1, 1. What are we going to get? 1's complement is nothing but flipping the values, right? 1 will become 0 and 0 will become 1. Dattatreya and Karthik, any confusion?
No, nothing
Here,
is.
yeah,
No,
so
sir.
negation of binary number, and we need to flip the bit values because we are using negation. Negation is nothing but like zeros will become 1 and 1 will become 0. Once we flip the bit values, we need to keep the sign bit aside. Okay. And then we need to calculate first complement. First complement is almost like flipping the bit values, like a negation of number. Okay. Here we calculated binary number, and then we flip the values because it's a negation, and then we need to keep the sign bit aside, and 1 is a sign bit, so the output is going to be a negative number. And we got 1, 1, 1, 0, 1, 1, 1. First complement is again flipping the values. 1 will become 0 and 0 will become 1. So what do we get? 0, 0, 0, 1, 0, 0, 0, right? And it's not just 1's complement. We need to calculate 2's complement. So 2's complement is nothing but 1's complement plus or minus 1. The 8 is a positive number, so we need to add 1. Okay, got it?
Okay. Yes.
Yeah, and then the final result is going to be 0, 0, 0, 1, 0, 0, 1. And let me show you the addition table. So if we add 0, 0, it's going to be 0. 0, 1, it's going to be 1. 1, 0, it's going to be 1. 1 plus 1, it's going to be 0. Here we have what, like 1, 0, 0 is going to be like this. What do we have? 0, 0, 0, 1, 0, 1, 0, 0. And what do we need to do here? We need to add 1. Based on the addition table, it's all 0, 0, 0, 1, 0, 0, 0 and 1 will become 1. Okay. Now what is 0, 0, 0, 1, 0, 0, 1? 2 to the power 3 plus 2 to the power 0, right?
Yes.
8 plus 1, which is nothing but 9. And as we know, we have to keep sign bit aside, right? Sign bit here indicates it's a 1 for 8. For 8, we have kept one sign bit aside. Here the sign bit is 1, so 1 indicates a negative number. That is why we need to make it a negative number. Bit confusion, but it's going to be very interesting concept. If we do more than like 2 or 3 examples, you will understand well. Any questions till now? So
No.
if you understand this formula, then you will understand this. So if we have something like negation of some number, we need to calculate the binary number, and negation of this is going to be nothing but flipping the values, and then we need to keep the sign bit aside, and then once complement is again flipping the values. 0 will become 1 or 1 will become 0, and plus 1 or minus 1 depends upon the type of the number we have. And at the end we will get some number, right? Result we get based on the sign bit, it's going to be a plus or minus 1, plus or minus. Okay, and it's not necessary to learn it for the sake of learning machine learning. It's nowhere related to it, but just for the sake of understanding Python concepts, I explain this. Let's take another example, and let's take 6. Karthik, explain negation of 6. Negation of 6. Negation of 6 is, sorry,
First,
bitwise negate is -7. So explain me how we got -7. What is the binary number? 0
zeros,
1
1, 1,
1
0.
0, right?
Yes.
0 1 1 0, right? What we have to do first?
Now, first 1, 0, 0.
Let's take 8-bit one instead of right, binary of 6. Yeah. Now
First 1, 1, 1, 1. 4 ones.
1 1 1 1.
Yeah.
1 0
1, 0,
0.
0.
Yeah, this is negation, right? And then
Yes.
we need to, what we have to do? The next step is
A sign or
sign
sign.
bit.
That is a
Sign,
minus
sign bit is 1, so it's going to be
1.
minus.
Negative.
So the output
Minus.
is going to be a negative number.
Negative. Yes.
Yeah. And then we need to calculate first complement. What is
First
first complement of this
That
one?
is 0, 0, 0, 0.
Let's do this. 1 0 0. Okay, now it's better. Okay,
Yeah,
0
0,
0 0
0, 0, 0. One
0
more
1
0.
1 0, right?
Yes.
And then we
Yes.
need to, whether we need to add plus, or whether we need to add 1 or minus, subtract 1.
Here we have to subtract 1 since it is a no, sorry, it's an integer.
Yeah,
Plus 1.
6 is a positive value, so it's going to be
Positive.
1.
Plus.
And the next one is like, what are we going to get? 0 0 0
Yes.
0
0,
1 1
1,
1, right?
1, 1.
Yeah.
Yes.
And what is this? 1 1 1. It's 2 power
Yes. 6, 4,
2 power
11.
2 2 power 1 plus 2 power 0, right? 4 plus 2
Yeah.
plus
4, 2 plus 6, 1, 1, 7.
7. But its output is going to be a negative number because
Negative.
sign bit is
Yes.
1. That is why we got -7.
Minus 7.
Yeah. And I have given the negative table also here. It's not just addition, a subtraction table also here, bitwise subtraction. Dattatreya, let's take a negative number and find it out. Let's take -6. What do we got? 5. Explain me how we got 5.
First, negative of 6 was 1 0 0 0 1 triple 0.
Right. So it's going to be like this, right? 1 0 0 0 1 1 0.
Yes.
The very binary number is itself, it's 1 0 0 0 1 1 0.
Sir, I was
Not
unable
0
to
0 0.
see your screen, sir. I was unable to
I
view your
think you
screen.
should. I think you should minimize, this one
What?
with chart window and other things. What about
Uh,
Karthik? Karthik, can you see my
Yeah,
screen?
I can see. Yes, yes, I can see.
Yeah, I think you should minimize it, Dattatreya.
how, sir? How?
I don't know what what all the windows you have. So minimize the chat window first, and then you
I
will
don't
get
have
some
any
space.
chart window, sir. Yeah. Can you try?
No, even if I give a present
No, you can
fractions,
increase
it's
the
going,
window size. You can increase it.
It is already at 80.
You just increase in that case.
then make it 100 and see. It will
100.
change.
Can you type it once?
Huh? What is that?
I was currently able to see your notepad, sir.
Yeah, that is what I am showing. In fact, binary
Ah,
of
okay.
-6.
Okay,
Okay.
fine, sir. Fine, sir.
Binary, yeah, binary
I
of
thought you
-6.
were something writing in Jupyter, not in notepad.
No,
Okay.
not in Jupyter. So, yeah. Binary of -6 is 100 and 0110. Karthik, you understood like why we got 100
Yes, yes,
of 0000?
yes, yes.
That
Because
was
it's
clear.
negative number, the sign bit is always
Negative number.
going to, yeah, 1.
-1.
And yeah, our negation of this, right? We need to
Yes.
calculate the negation of this. What do we get? It's going to be, yeah, by Dattatreya. Next.
And put aside this sign bit.
No, what do we get here? So negation of this number. Negation of this number, what do we get
First,
here?
we have to do the ones complement, sir. Let us flip the bits.
Okay, let's remove
So
this one.
0, yeah, 0,
Yeah.
1, 1, 1,
0 1 1 1
1, 0, 1.
0 0 1. Okay, and then next,
Then put this sign bit 0 aside.
what is sign bit?
So
0.
last, yeah,
Output is going to be what? Is it going to be a negative number or positive number? The
positive
final
number.
positive
Positive.
number. So, okay, plus 1 1 1 1 0 0 1, right?
Yeah,
Now we need to calculate one's complement plus 1 or minus 1.
-1.
Okay, yeah, let's calculate one's complement. One's complement of 1 1
0,
1
0,
1
0,
0 0 0 0
0,
0
0,
0
0,
1 1
1, 1,
0,
0.
right?
Yeah,
And we
that
need
is
to
6.
subtract, yeah, go ahead.
That is 6 minus 1. That is 5.
6 minus 1 5.
5.
No, not that way. Binary subtraction is going to be a bit different. 0 0 1 1 0. Here we need to calculate -1, right? And let's look at the binary table, bitwise subtraction table. Here we have a table, right? It's 0 1 is going to yield out as 1, borrowing 1. Got it? 0 1. Here we have 0 1, right? 0 1, right?
Okay.
So to borrow 1 from here, that means this will become 1. The result is going to be 1. What we
Okay.
got here, 0 1. If we have 0 minus 1, 0 minus 1, the result is going to be 1, and we need to borrow 1. So if you borrow 1 from here to here, this will become 0.
Yeah.
Okay. Now, yeah. Now this will be 1,
0.
0. The remaining one all zeros, right?
Yeah.
And what is this?
5.
2 to the power 2 plus 2 to the power 0.
0.
4 plus 1. Is this going to be a positive number or negative number? 5 is a
Positive.
positive number or positive number because the sign bit is 0, which indicates that it's a positive number. That is why we got 5 here. So when we calculated -6, we got 5 here, right? I think hope you understood, like you understand it very well, like how to how to calculate a negation, bitwise negate of a positive number and a negative number. The only difference is we need to calculate we need to add or subtract. That is one. That is the first point. And the second point is make sure that you keep the sign bit aside. If it is zero, it's going to be positive number. If it is one, it's going to be negative number. And you have to follow this table. Okay. Bitwise for bitwise addition is going to be this, and bitwise subtraction is going to be this. I will provide it in Trello. So everyone can able to access Trello, right?
Yes, sir.
Karthik,
Yeah, I did not check actually.
so you have to check your inbox. I already sent an
Yeah.
invitation to you. It's going to be like this. Yeah, this one. I've already shared files,
Okay.
the installation part and the operators and markdown basics. All the files been shared. I think already been added and you haven't accepted it. Please accept it, and this even the today's session files will be shared in Trello itself. Okay.
Okay. Yeah.
Okay. Any questions till now? The confusion part is over.
No, sir.
Yeah. And what we had, like yesterday we have discussed arithmetic, comparison, logical, and today we had discussed about bitwise operators and assignment operators. I haven't discussed about right shift, left shift, and bitwise AND, right? And this, let's take x equal to x. Let's take x bitwise and let's take 5. This is nothing but x equal to x bitwise and 5, right? For example, if x equal to 2, this is going to be like this: x equal to 2 bitwise 5. So, and we know how to calculate bitwise AND of two numbers, right?
Sir, can you calculate this for -8?
-8. Okay.
Yeah. Not here. Just the negative tilt of -6 instead of -6. I was
Okay,
asking
fine.
for -8.
-8. Fine. Go ahead. We got 7, and let's calculate how we got 7, right?
Yeah.
This is 8 and 1 0. Sorry. Okay, let's do it here itself. Okay, it's going 1 0 0 0 1 0 0 0, right?
Yep.
Binary of -8. And what we have to do here, the negation of, anyone sent a message? All right, I think you have accepted the invitation, right?
Yes,
Karthik?
yes, I have.
Right.
Yes, yes.
Yeah, 1 0 0. Okay. Negation of this, and what is the negation of this? It's going to be 0 1 1 1 0 1 1 1, right? What is the sign bit? 0 plus yeah,
It's a negative value.
sign bit is 0. No, sign bit is 0, right? Sign bit is 0. See, 0 indicates a positive number.
Time 0. Positive.
Final output is going to be positive
Positive.
because sign bit is 0. 1 1 1 0 1 1 1. What is one's complement of this? 0 0 0 1 0 0 0, right?
Yes.
And we need to add 1 or -1, means we need to subtract 1.
Subtract -1.
1 0 0 0 -1, because there's a negative number, so we need to subtract 1. What do we get here? 0 0 0, and it's going to be 0 because we need to borrow 1 from here to here.
Yeah.
Okay, it's going to be
Okay.
0 1 1 1.
That's what I was unable to understand that the same point,
Okay,
sir. Here.
all right.
Last.
Yeah, now let me show that. So here we have what 000 1 0 0 0, right? 0 0 0 0 0 1 0 0, right? Here we need to detect 1,
Yeah.
right? So we don't have anything here, so we need to borrow 1 from here to here, right? This will become 1. So the values, the zeros in between will also become 1. Sorry. And this will become 0. Why? Because we already borrowed this 1 to here, right? That is why it becomes 0.
Then
Now
it
if
is
you
7.
now now as per the bitwise subtraction table, 0 minus 1 is 1, and the remaining and all 1, right? Because we have 1 here. 1
1 0
1
1.
0, and the remaining and all zeros.
Yeah. Understood, sir.
And this one, what is the value? Like 2 to the power 2 plus 2 to the power 2 to the power 1 plus 2 to the power 0, right? It's 4 plus 1 plus, sorry, 4 plus 2 plus 1. What we have, what 6 plus 1, 7. 7 is what? Like, is it a negative number or positive number?
Positive.
Sign with 0 is going to be positive. So we got 7. So we got 7 here. Yeah. Any questions, Karthik?
No.
Yeah. The only thing is you need to follow the table, bitwise table. If it is addition, if it like you have to follow this. For subtraction, this one, and you need to follow this tool. Remember this, you will understand like how to calculate this. The only another thing is when we borrow something, the values in between, if at all those values are zeros, it will become 1. Okay. Fine. Move on to the next one, math library. The simple, interesting one too. So if at all you want to import any library or module, what you have to do is import. You need to write the keyword import and the library name or the module name. Here we need to import math library. So import math, import, right? There are different ways to import it. I will explain that later. But now understand like how to, this is the way to import a module. Sometimes you may want to have an alias. So in that case, we need to mention as, just like empty, something like that. But now this is alias is not necessary. The math itself very short, so it's good enough to start with. And there are different methods that it's going to provide. Let's start with exponent, exp. Exp what? E power. You know what is exponent, right? E power. So if you mention e power some number here, it's going to be like this. E power the number. Here we have given 2, right? If we give 2, it's going to be like 2. E power 2 is nothing but 7.389 something. Any questions? Especially those who don't know what is exponent may get questions. I will explain what is exponent later when I explain when we get into the pandas data analysis part. Karthik, any questions?
No.
Yeah, and the logarithm of this, like we have a method called log. We can give any number we want. Let's take 2. It's going to be 0.69. By default, it is the the base is e. Okay. If at all we want to calculate, if you want to mention explicitly, if you want to mention base explicitly, we can mention it here. For example, log base 2, we can write like this. If you want to mention log base 10, it's going to be like this. Okay. If you leave, no, if you don't mention anything here, it's going to be E, log base E. Okay. Any questions?
No.
Yeah, yesterday we discussed about power of, right? Power, 2 to the power something.
Yes.
How did we do that? Like, what is the operator we have used?
Power.
Asterisk.
Yeah, asterisk, asterisk. 2 to the power, if at all you need to calculate 2 to the power 3, it's going to be 2 asterisk, asterisk 3, right? There's another way. In math library, we can use POW. Let's take 2 to the power 3, right? 2 comma 3. We got the same result. The only difference is it's going to yield out a float value. Okay. And this is much more readable than this. So try to use this one whenever you need to calculate power. So whenever someone reads your code, right? This is going to be much, much more readable than this. Especially those who got habituated to other programming language can understand this one better than this. They may not know what is asterisk, asterisk. And the next one is square root, SQRT. Let's take 4. What is square root of 4? It is 2, right? It's 2. Okay. And yesterday we have missed calculating floor and ceiling values using, I tried with NumPy. NumPy doesn't have any method, and math has library. I mean, math has a method. Just take 2.5. What is the floor value of 2.5?
2.
Yeah, so we got 2. And if we have ceiling, I mean, we have another method called ceil to calculate the ceiling value. What is the ceiling value of 2.5?
3.
3. And we can, what is the pi value? So pi value is something like 3.14159 something, right? We can make use of math.pi. So usually what we do here is pi something like this. We store it in a variable and we make use of it in the programming code. Okay. So this is much more readable than writing something like pi equal to 3.14159. Okay. Yeah. Any questions till now, like math library? We have seen how to calculate exponent, logarithm, power of, square root, ceiling value, and pi value. Yeah, and then next one is variables. We have already seen how to, how to create a variable, how to instantiate a variable, and how to store a variable. Let's take, we not to write anything like int something like that. In other programming languages, we have to write int and all. So it's not required. So x equal to 23, if you mention, if you assign an integer value, it is going to take it up. And if you check the type, it's going to be integer. And if you want to store some string, let's take machine learning. Check the type, it's going to be string. So it automatically detects and finds out that it's a string. Another interesting thing is, let's take x equal to 23, right? If what is the type of this? X integer. If you store 23.5 something, some float number, it automatically changes back to float. Let's take x equal to, I'm storing the same, I'm storing a string value in an integer variable. Let's see what are we going to get. So automatically it gets changes. So this is string now. So it's dynamically typed. It automatically changes. In other languages, when we write something, when we instantiate a variable, we can store only that particular data type values, not any other, right? But here in Python, automatically, dynamically changes its type. And the next one is the different data types that we have. Let's see. Bool, as you know, what is bool, nothing but true or false. In Python, we will start with caps, capital T and capital F. So bool of true is okay, like this. And if you want to, okay, type, right? Type, yeah, this is bool. And type of false is bool. Let's take a variable 23. We have already seen it's an integer. And if we take 23.5 as a float number, check the value, it's going to be float. And the complex is going to be like this. Usually in mathematics, we write complex number like this, right? X plus y I, something like this. I here indicates is an imaginary number. Whereas in Python, it's going to be j. Let's take 2 plus 3j. Check the type. This is going to be complex. Any questions till now? We have
nothing.
seen different data types: bool, integer, float, complex, string. And string we haven't seen it. Let's see. Machine learning is going to be type as a string, right? str. Now the interesting part starts, like list, dictionary, tuples, and sets. List, dictionary, tuples, and sets are data structures. As explained yesterday, like a list is going to be like this. It's going to be wrapped in square brackets. We can have any kind of values. It need not be just integer. We can have float values or mix of something like this. We can have string values also. It can contain any data type. It can even contain a complex number like this. Okay. If you check the type, it's going to be a list. And the next one is dictionary. Let's see how we can create a dictionary. My dict, it's going to be key value pair, right? So let's take key 1, value 1. It's going to be like this: key 2, value 2, key 3, value 3. And it has to be wrapped it in flower bracket. You can see it here, right? This indicates a dictionary. Let's create 1, 0, 0. And the keys can be integers or it can be strings also. So it not to be just integers. 1, 1, 2, 2. If you check the type of my dict is going to be dict, dictionary. Dict stands for dictionary, right? So any questions? The first of all, what we need to remember is what are we going to wrap up with? A list is going to be wrapped with square brackets, whereas dictionary is going to be wrapped with flower brackets. That is number 1. And list can contain any kind of values, whereas dictionary is going to be in the form of key value pairs. And it not to be integers. The keys need not to be integers. Even we can write something like this. It's still a dictionary. So if we want to fetch data values, let's take 0 itself. We can write like this. So we got, we have mentioned key here and we got the respective value, right? Another thing is tuple. Tuple is going to be wrapped in this one, around brackets. I will explain the difference between list and tuple later. For now, understand that this is the way we can instantiate tuple. Square bracket is like list is what? Like it's going to be wrapped in square brackets, whereas dictionary is going to be wrapped it in flower brackets, whereas tuple is going to be wrapped it in round brackets or parentheses. Another thing is set. Set is going to be wrapped it in flower brackets. just like the way dictionary, but it's not going to be in the form of key value pairs. It is going to have some values, num1, num2, something like this. The important thing that we need to note down here is, see this value, my set, right? Let me add a duplicate value. Here we have 2 5s, but if you check the output, we have only 1 5. That does not entertain duplicate values. If we at all we provide duplicate value, it is going to remove it. Okay, that is the main difference between a list and a set. Any questions till now? List is going to be wrapped in a, yeah, go ahead.
Yeah, you said in set we can use only numerical value or any string also.
Which one, set or
Set.
okay, let's see. We have, right?
Okay. Yeah. So it will also delete. I mean, remove the duplicate values also.
Yeah,
Even it is a string
even
also.
If, let's try this. Yeah, we have only one, right? And
Yeah.
this is a case sensitive. Python is case sensitive, so you can see it has not removed.
Yes, since it is
Case sensitive. Yeah, main important thing is, like, let's not worry about the difference between list, tuple, dictionary, and sets. We'll discuss that later. For now, understand how to declare it. Okay, list is going to be wrapped in square brackets, whereas dictionary is going to be wrapped in floor brackets. Tuple is going to be wrapped in round brackets or parentheses, and set is going to be wrapped in floor bracket, just like the way we we use it in dictionary. But there is a major difference between dictionary and set. Dictionary is a key value pair, whereas set is a set of values, right?
Yes.
Yeah. And then the next one is typecasting. Typecasting is nothing but converting one data type to another data type. Let's see how we can do that. Let's take x equal to 23. What is the type? Integer.
Yes.
And if you want to convert this to a float, just use float method. What we got here is 23.0. 23.0 is a float. Let's assign it back to x. Check the type. This is float now. Okay. The same way we can, let's take 23.2 or 23.5, right? Check the type, float, and convert this to integer. We have to use int. Just like the way we have used float, we can use int. Let me minimize this. Yeah. Int. And if you check the type, it is int, and check the value, it is 23. Automatically deleted the decimal part. Right?
Yes.
And complex number, as explained before, complex number, what we did, x equal to some x plus y j. It is going to be in this format, right? Let's take 2 plus 3j, and type is complex. Otherwise, we can make use of complex method, complex function. 2 comma 3, see, you can see the result, 2 plus 3j. This is much more readable than this. Okay, so we not to worry about whether it is I or j, if you remember this function. Okay, any questions?
No.
Yeah. Dattatreya, is it boring? Basics
So,
are a bit boring, but we have to bear with it. Yeah. Yeah, let's take strings. Let's declare a string. We have already seen how to declare a string. The thing is, like, we can either use single quotes or double quotes. It's not going to be any change. Let's see the type, str, right? Let's change this back to double quotes. It is still a string, so either you can use single quotes or double quotes. Not going to be of any difference. There is a specific case where you need to use, only single quotes or double quotes. I will explain that later. For now, understand that we can use either single quotes or double quotes to declare a string. And if you want to check the length of a string, you can use len method, L-E-N. What we got? 16. Why we got 16? Because this is of 16 in length. 1, 2, 3, 4, 5, 6, 7. Space is also we need to calculate. 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. And Python is a zero index one. What does that mean? So if we mention machine learning, right? It's going to start with, okay, let's omit this part. It's going to be like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do one thing, like let's give some space to understand the index well, now better. Right? Maybe we need to give more space here. Yeah. 11, 12, 13, 14. So this is going to start with, I think I have missed some value, right? This is 13. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, all right. So I think
Space.
yeah, right. Space. 8, 9, 10, 11, 12, 13, 14, 15. Yeah, this is fine, right? Now it's much better. Yeah. Now if we refer it like x of, let's take 2, we got C. Why we got C? Because x of 2 is C. Okay. And x of, let's take 14, what are we going to get? What do we get?
14 N.
Karthik, am I
Yeah,
audible to you now? I'm
yeah,
sorry,
now we
internet
can.
got disconnected. Internet got disconnected. Yeah. I'm using secondary connection.
Okay.
And where got disconnected? Is it from here?
Yes.
X of 2 is C, because right at this index 2 we have C here. So what do we get here? X of 14?
N.
N. And Dattatreya, X of 8, what do we get here? Dattatreya, is he there? Yeah, Dattatreya.
X of 8, yeah, X of 8 was L.
Yeah, it's capital L. And what about X of 7?
Space, none.
Exactly, it's a space. Yeah, it's space. It's not null, it's space. Sorry, it's not null, it's
Yeah,
space.
sorry.
Yeah, and if at all we want to change some value, like let's take x of 7, instead of space, if we can, no, if we want to mention underscore, it's not going to work because strings are immutable. Immutable in the sense we can't change, we can't take a particular index and assign some value to it. But having said that, we can completely rewrite it. Let's take artificial intelligence. We can completely rewrite it, but we can't take out a particular value and assign it to some other value because strings are immutable. There's one thing you need to you guys need to remember. Okay, and the next one is booleans. We haven't seen. Okay, you haven't seen if conditions, right? If condition we write like this: if and the condition and the statements. Okay, and in Python we give 4 space as indent. Usually in other programming languages it's going to be like this, right? A statement, but in Python it's going to be a colon and then 4 spaces or tab. Okay, let's write 2 greater than 3, print 2 is greater than 3. What happened? 2 is greater than 3. So 2, we haven't got any result. Can anyone explain me why we haven't got any result? Even though I have clearly
It was
mentioned 2 is
false.
greater than 4. Yeah, if
2 is greater.
false, right? So it's not going to get into that no, a loop. That is why we haven't got the result. Let's change this back to 2 is less than 3. Less than 3. We got the result, right? And the condition always need to be true to get to get this statement to get this statement executed. Otherwise it's not going to get into the structure. For example, if you mention false and mention like it is false, it's not going to get into the structure, right? And if you mention 0, it's not going to get into it. In Python, false is nothing but 0. Check this. False equal to 0 is true because false is equal to true. That is why we got true here. There is another case where it's going to be false, like none. It's not going to print anything. So it's going to be like this. If it is false or 0 or none, it is not going to get into that structure or the loop. Okay. There is another case where it's not going to get into it. If it is no, it may not be just 0. It can be even a float value like this 0.0 or 0.00 plus 0j complex number. It's not going to work. Let's see this. It has not printed anything because this is false. Okay. And another case where it is not going to work is if it is an empty set or list or dictionary, it's not going to work, or tuple. Let's take list 1 and it's an empty one, right? List 1. It has not printed anything because list 1 is empty. Okay. And it works for dictionary also. My ditch, it doesn't work. And my set, it doesn't work. It has not printed this. And my tuple, let's create a tuple. Yeah, it is false. Sorry, what happened here? Sorry, yeah, I haven't written. Yeah, it is false. Any questions till now? Like in what case it's going to be falsify and what case it's going to be true? It's going to be false when it is false, or zero. It not to be zero, it can be 0 or it can be 0.0, right? It can, if it is none, it's going to be false, falsify value. If it is empty string, empty list, or empty dictionary, or empty tuple, or empty set. You have to remember these values. I'll give the script with all that list, but you need to remember these values. Karthik,
Yeah.
any questions on this?
No question.
It's going to be falsify when it is false, 0 if it is whether it is complex representation or a float representation. If it is 0, it's going to be false. The other one is none, or empty data structures like empty list, empty dictionary, empty set, empty tuple. Right? Dattatreya?
Sir,
Yeah, any questions?
no, sir, no.
All right. I think we better stop here. There are two main things we have discussed today, right? One is bitwise operators and negation of it. And what we have discussed today: bitwise operators and math library, variables, dynamically type. Python is dynamic type, and different data types that are available in Python, and typecasting, converting from one data type to another data type. So one thing that I have missed here. So let's take 23, right? So if we x is what type of x is string, and if we convert this to an integer, let's take int, it is going to work as long as the value in it is compatible to convert it to integer. For example, if we write machine learning something like this, convert it to integer, you get an error because it's not possible to convert this value to integer, right? It has to be compatible. Integer and float are always compatible, so it's not going to be a big deal. So when you convert a string to an integer, you have to be careful. And converting integer to a string is not going to be a big deal. So you can convert anything, right? For example, x equal 23. So let's take 2356, something like that. And str, you got a string. And then we discussed about complex number, making use of complex function, and then strings. We have discussed about strings and booleans. Tomorrow we'll discuss about special characters in a string and few other things like data structures, lists, tuples, dictionaries, sets. We'll discuss it tomorrow.
Okay.
Yeah, Dattatreya and Dattatreya, any questions?
So far, no, sir. No.
I think we haven't recorded it. Oh God, we haven't recorded the
We
last
recorded.
part. All right,
We
it's
recorded.
recorded. Okay, it is recording. Good. Let's stop it here, and if you have questions or feedback, stay on home, or else you can log off. And have you got the recording, yesterday's recording?
Yes, sir.
From my side, no, sir. Maybe I have to call Venkat, sir. I was a little busy yesterday, so I didn't
Okay,
call.
what is your WhatsApp number?
Same, sir. Whatever you call me, if
No,
you
it
reach
has
me.
not. It has not shown up. That is why. Okay, let me add it in WhatsApp. I think in WhatsApp he has shared that link.
Okay, sir. Okay, sir.
Okay, let's do one thing. I'll keep it in Trello. See, anyway, you have access to Trello, right?
Yeah, I heard, sir.
Yeah, you can get the link here.
Yeah, okay, sir. Yeah.
And today's session also I will share it here
Okay, sir.
and WhatsApp also. Yeah. Any questions, feedback, or else you
Yeah,
can
no,
log
sir.
off.
Yeah, I'm logging off, sir. Thank you.
Thank you.
Have a nice day, sir.
Karthik?
Bye.
Yeah. Actually, I have a question.
Is it a bit boring?
No, not boring. I just want to ask you details. Apart from,
You want
I
to
mean, today's class, yeah.
go ahead. 1 second. Let me stop the recording.